Hello, everyone. Good morning. I'm super excited to be here. This is actually my first time in Brunei, so I'm so glad to have the opportunity to meet you all today. And thank you so much for the organizers as well for setting this up. So yeah, the title of my talk is Machine Learning on the Web. But before I talk more about that, I'd like to introduce myself a little bit. So yeah, my name is Galuh. Currently working as a data engineer at Gojek. I'm based in Indonesia. And I think someone's mentioned that Gojek is actually like doing pretty much a bit of everything. We're like a super app company that is currently operating in several countries in Southeast Asia. We do ride-hailing, food delivery, laundry. We can even get like a makeup artist to come to your home. Basically everything straight from your phone. But before working as a data engineer, I actually worked as a freelance web developer, which is why I really love dabbling in the intersection of like the web and data, which is what I'm gonna talk about today. So oftentimes when we talk about machine learning, it's pretty much often associated with writing, Python scripts or like R scripts that run on server side. We rarely hear people talk about doing machine learning with JavaScript or like running or doing machine learning entirely on the browser client side. And that is until we actually start seeing some tools that enable us to do exactly that. Now, I think this is exciting because it opens up a lot of possibilities. The first one is that it makes machine learning more accessible to users because browsers are actually like one of the most accessible platforms. So that's great. And the second one is that it also makes machine learning more accessible to developers because JavaScript is like one of the most widely used languages in the world. So I think right now machine learning is more accessible than ever, and I think this is a very exciting time to actually, for everyone to start learning about machine learning. So these are the links to the slides, so if you want to follow along, feel free to access it. And I'm also going to show you some applications that I built. Every code is open sourced in the GitHub link, so feel free to open up the code, open up the repository as well, and follow along. Okay, so yeah, hopefully everyone's taken note of the links. Okay, cool. All right. So before I show you the applications and whatnot, I'll spend a couple of minutes talking about some things about machine learning that you might want to know if you want to start building your own machine learning applications. So we can start with the question, what is machine learning? So it might be difficult to find the definition that everyone can agree on, but maybe we can refer to the definition. This definition that was defined by the person who actually coined the term machine learning, Arthur Samuel. He's a computer scientist. So he says that machine learning gives the computers the ability to learn without being explicitly programmed. So you don't have to write a bunch of if-else expressions to teach computers. They can learn all of those by themselves. So we want to teach machines how to do certain tasks, right? And it's like when we're teaching a person, we may need to give them sources to learn from, like books or websites or encyclopedia for them to read. It's pretty much the same thing when we're teaching computers. And this is where data comes from. We need to give them something to learn from, and in this case, it's data. So the data itself really depends on the task that we want computers to learn. So let's say that we want computers to learn how to classify images as either a panda, a red panda, or a sloth. We need to give them the relevant images with labels as well, so they can tell that, oh, a panda looks like this, a red panda looks like that, a sloth looks like this, and so on and so forth. But it's not just pictures, actually. We can also do this with other data, such as voices. So the reason why tools like Google Assistant is able to understand what you're saying is because it has learned by listening to hours of people speaking different things, even with different accents, so that they can recognize a lot of what you're saying. They can understand your statements. They can understand your questions. Now, if you want to make such applications, you definitely can, but you need the data first. So voices are kind of tricky because it's really hard to find recordings of voices in various situations or environments with different accents. that have been labeled. One of the greatest resources that I can point you out to is something called Common Voice, which is initiated by Mozilla. So it collects and open sources voices from all over the world for a lot of languages. And since it's open source, you can also use this too. So there is other kinds of data, for example, like text. So now text is relatively easier to find because it's pretty much everywhere. You can like get it from Wikipedia. I think if you Google it, you can find like Wikipedia dumps that you can like use immediately. You can also like create a scraper scripts for, if you want to scrape news from websites, you can write your own scripts and get your own data. You can also get data from social media. So I think Twitter has an API that you can use to get like tweets from your timeline or even other people's public tweets. So that's great. The next thing that I want to talk about is features. So a feature is something that you'll hear about often. A feature is a characteristic or property that you can find in a problem that can help us make a prediction. So features can be numeric, it can also be like categorical. In this case, let's say that we want to predict the price of a house. The features can be things like a lot area, or like how many floors do the house have, the year it was built, and so on. So these features may help us determine the price of a house, and thus it can help us build a model that can predict the price of the house. So yeah, these are, I'm not sure if you can see it, but it's basically a table that consists of like features like a lot area, what else? The style of the house, the year it was built, and so on. And target variable is like the variable that we want to predict. In this case, it's the price of the house. So yeah, but for some cases, like let's say computer vision problems, the feature here might be different because you're not going to have like tables that explain what everything is. So in this case, it can be pretty different. Like for example, the features here, instead of like the number of floors on the house, instead you have something like the colors that are contained in the image, or like edges, or like shapes, and so on. So yeah, computer vision might be slightly more complicated in that sense, but luckily advances like deep learning enables computers to know the features that they have to look for themselves. So we do not really like need to extract everything manually like we would if we were building a model to predict house prices, for example. All right, so another thing that I want to talk about is something called model, which is something that you'll also hear often. So a model, we can say that it is a kind of like a mathematical representation of a real-life process. So let's say that the real-life process that we want to represent mathematically is, predicting the price of house. The mathematical representation might be something like a simple equation. I'm sure it's not in real life. It's probably not going to be like this, but this is an example. It probably looks like this, with coefficients and variables like number of floors, number of rooms, and so on, which determines the house price. Now, when building a model, oftentimes we don't get it right straight away. We may start with like random coefficients and try to measure how far away we are from the real life situation by measuring the error. So ideally, we want to minimize this error, meaning that the result of our prediction should be as close to the real world as possible. So we probably need to do this in several iterations until we get a pretty small error that is acceptable. So yeah, hopefully like in each iteration, our model should be able to learn better coefficients or weights that will minimize the error until we get an error that we're pretty happy with. So yeah, I think it's pretty impossible to have like a zero error, but we should be able to have like an error that that is acceptable. Okay, so that's all about the machine learning stuff. Now the next question is like, can we do all of these machine learning stuff entirely on the browser using JavaScript? Now, if you asked me like 5 years ago, I'd probably say no, but today we can definitely do this. So in 2017, Google released a library called deeplearn.js. So deeplearn.js allows us to train neural networks on the browser, and we can also like use existing models to predict something. And in 2018, deeplearn.js evolved into what we now know as TensorFlow.js. So if you have heard of the Python version of TensorFlow, so it's pretty much the same thing, but this is like the JavaScript port of TensorFlow. So yeah. And several cool things about TensorFlow.js is that first, you do not really need to install anything or any dependencies. So you can just like load the JavaScript script, and then it will, contain everything that you need to run machine learning stuff in your browser. So second one is that it allows for a lot of interactive applications, because, for example, if you write in JavaScript, it works really nicely with your browser. You can obtain data from various sources like your microphone or like webcam. It's pretty much straightforward if you do it in JavaScript. It's really hard to achieve this kind of thing in Python and R, so that's really awesome. And if you're like concerned about privacy, having neural networks that work in your browser means that you do not really need to send your data to a server. So since everything is like working on your browser, everything is working client side, so there's no data that you need to send to the server. So if you're concerned about privacy, this is also very great. So training and processing machine learning models oftentimes requires large computational power. And sometimes we even need accelerators like graphical processor unit or GPU so that we can redistribute these calculations to many threads. Now, TensorFlow.js utilizes something called WebGL, which is a JavaScript API that is usually used for like heavy graphic stuff like rendering interactive 2D or 3D graphics on the browser without having to install additional softwares. And TensorFlow.js uses WebGL so that it can use the GPU for the heavy math calculation stuff. Okay, so when I decided that I wanted to learn TensorFlow.js, I went to its website and I saw like this piece of code in the tutorial. And there are just so many terms and like things that I feel like I have to understand before I actually like get to build my machine learning application. But the thing is that I personally feel like I learn best by doing. So I prefer like building the applications first before diving deep into the machine learning theory stuff. So I decided to like look for another tool. Like, is there another library that can help me out with this? Is there another library that can help me build machine learning apps more quickly just to get me started? And it turns out there is. So there is a machine learning library for JavaScript built on top of TensorFlow.js called ML5.js. So this is like the higher level library of TensorFlow.js. It is also recommended by TensorFlow.js on the Getting Started guide. So if you're new to machine learning, you might want to start with this. So what it does is that it allows you to code machine learning programs without having to deal directly with like the low-level details like tensors and optimizers that we might not be familiar with. So the library gives you like access to a lot of like machine learning algorithms and models in the browser with a friendly API. Okay, so what are the things that you can do, when you're building machine learning applications? So there are like three things that you can do. I'll be going through them one by one. So the first one is that you can run pre-trained models. So pre-trained models are models that someone else has created, that someone else has trained. Now you can just use them to make inference or predictions on new data right away. So I created this application, which is an image classification web application using ML5.js. So it accepts input in file upload and webcam as well. So is it playing? Yeah. So you can upload an image and then it will tell you, I think it's supposed to say bicycle. So it will tell you like the prediction of what it predicts the image as. Okay, so I'll explain about one of the models that I use for this app, which is called MobileNet. So that's the name of the model. And you remember that we need data to learn from, right? So the model has to learn from somewhere. MobileNet learns from a huge data set called ImageNet, which is a database that consists of 14 million images. So you can say that MobileNet has learned a lot. And images from ImageNet has labels like these, for example, people, child, house, and so on. If you want, you can like Google and check out its website. It will show you like what images are there, what are the labels, and so on. So how it works is that, say that we have an image, and then we want to predict what it is. We can just like give this image to MobileNet, and it will just guess what it is. So it will also output a number, which explains how confident is MobileNet on guessing that this image is of a bicycle. So for example, the confidence is about 0.78. Okay, so I'll walk you through some parts of the code. What I want you to see is that we can see here the script. This is the only thing that you need to have for ML5JS to run. So it's just like one line of script. There is no need to install any package because everything is client-side. So that's nice. You don't need to deal with, with dependencies and stuff. Right, so in a separate JavaScript file, first what we need to do is that we need to load the pre-trained model. Now for computer vision models, ML5JS currently has an image classifier method that you can immediately use. So you just need to insert the name of the model, for example, MobileNet, and it will get the model for you. And yeah, it currently supports 3 models, which are MobileNet, DarkNet, and DarkNet Tiny. I'll explain what are the differences between these models in the next few slides. So we can use the classify method to give our input to our image classifier that we have defined before. And it accepts HTML5 video element or image. So you can input both image or video. And the result will look something like this. If you print it out, you will get an array of objects that contain the label and confidence. So in this case, it will return the top 3 predictions. And yeah, so the application also accepts Webcam, and I think this is very exciting because it's pretty straightforward to do this in JavaScript because they already have a really nice API that you can use if you want to get data from Webcam, for example. And yeah, this part of the code shows how to get your webcam as an input. Okay, so the key here is that we're using a method called GetUserMedia, which is a method from Web API that is already available that lets you to capture a video from your webcam. So with this one single line, we're saving the video stream, and in the next line, we are going to give this to our classifier with the getPrediction method. We're giving this to our classifier so that you can predict what it is. Okay, so what's the difference between MobileNet and DarkNet and other models? So the key is that they're trained on different data sets. So they might have different labels and they might predict different things. So this might lead to different predictions. For example, MobileNet predicts this as a bicycle built for 2, while DarkNet predicts this as a mountain bike. So that's different labels. So when using pre-trained models, I think the key is that it's very important to know what is the data set that they're trained on to make sure that it really suits your needs, because it will affect your predictions. The next thing that you can do when you're doing machine learning with JavaScript is retraining existing models. So let's say that you want to classify images that are not in ImageNet. These are pictures of Indonesian musical instruments. I'm not sure if you also have these here, or if you're familiar. But I'm pretty sure MobileNet probably, these images are not in MobileNet, so MobileNet has, not in ImageNet. So probably MobileNet has never learned about these images before. So if we give them to MobileNet straight away, they'll probably output the wrong predictions. So you have to retrain MobileNet so that it can recognize these images. Now the question is, should we do the entire training from scratch? Because remember, ImageNet consists of 14 million images, and that's a very huge data. And training on such large data set will take a very long time, will take so many resources. It's pretty difficult to do. So the key here is that we can use a process called transfer learning. So transfer learning is the process of taking a model that is trained previously on another dataset, in this case the ImageNet dataset with 14 million images, and we can apply that to a different dataset. In this case, it's going to be our own dataset of musical instruments. Now, when trained on ImageNet, MobileNet has learned how to differentiate images by color, shapes, edges, and other features. So they already have this knowledge that they get from the training on ImageNet. What it doesn't know is that it doesn't know how to use this knowledge so that it can classify images as musical instruments as opposed to ImageNet labels. Now, with transfer learning, you do not need to teach MobileNet from the start. So we don't want to throw away the knowledge of differentiating color, shapes, and stuff, right? Because we're gonna be using that knowledge anyway to differentiate images. And MobileNet already has that, so we do not want to throw that knowledge away. So that's why we use transfer learning, and with transfer learning, the training process will take much less time with less computational resources, and we don't need too much data anyway. So yeah, and the great thing, it might sound complicated, like the first time I learned about this, it seemed like, you know what, how are you going to do this, right? But the cool thing is that ML5JS already has a handy methods that you can use to do this in just a couple of lines. Okay, so to illustrate transfer learning, I created a rock, paper, scissors game. So basically you play rock, paper, scissors with your computer, and the webcam will recognize your move and determine like whether you win or lose. So I'm using MobileNet for this. But MobileNet won't recognize my moves, right? Because I don't think like pictures of me playing rock, scissors, and papers are in the ImageNet dataset. So before that, I'll have to teach MobileNet first how they can like recognize my moves. Okay, so this is a recording of how it works. Is it playing? Okay, so yeah, there's the webcam, and I'm like teaching. I'm teaching the application how to recognize my moves by. Okay, so this is rock. I'm gonna add the images. This is paper, and then next. So I think I only like take about 10 to 20 images for each move, which is like pretty small data, right? Okay, so, and then it starts training. It also shows the loss. I'm not sure if you can see it. Yeah, and then I start the game. So, yeah, there's the countdown. And yeah, I show the rock, and then, okay. So yeah, I play the rock. It recognizes as a rock as well. And computer say scissors, so I win. Yay! So yeah, that's a demo. And okay, some code. So let's start with the HTML code. This is the part of the code with the button that trains my model. So yeah, this button. And then next one is that we also have the button to start training the model. And okay, so this is the fun part. We load our model using a method called feature extractor. I'll tell you later why it's called feature extractor. The input can be HTML, image, or video element as well. And since I'm using webcam, it's the input is video. And the key is that feature extractor will help to retrain the MobileNet model so that it would be able to classify our webcam video as paper, rock, or scissors. And yeah, so this is the model name. And then this is the input, where the input goes. I also have to like define a number of classes. Since we have rock, paper, scissors, I put 3. Okay, so yeah, now instead of like predicting my move as like bicycle or cup or vacuum or like other irrelevant labels, it now classifies my moves as, you know, rock, paper, or scissors. Okay, so how does this work? So usually image classification problems use neural network architecture called CNN, or convolutional neural network. So it has several layers, and these layers at the front here, their task is to, you know, to get features like shapes or edges, colors, and so on. And as I've mentioned earlier, deep learning extracts like their own features. So we don't need to manually tell them like, hey, you need to like look for colors or shapes and stuff like that. They'll just like do it on their own. So that's why the name is feature extractor. And these layers here at the back, these layers have the task of, you know, classifying. So given the features that the earlier layers have learned, how do they like want to classify these, right? So we do not want to change the layers at the front because these are very useful, and we don't need to like change that. But what we need to change is the layers here at the back with the classification task. So yeah, you can actually like check out the ML5JS source code and see like what parts of the original model are modified. It's the 3 layers at the back here. So you can also see that it modifies it so that instead of like instead of like the ImageNet models, it will like classify it into the number of classes here. Like 3, it will like modify the model according to our, the number of classes that I put earlier. So yeah, So this is the JS code. This code shows the function that captures the video. So it will label it as rock. So this is like the training process like earlier. It will like capture my move and then add it to the classifier to learn from. And we will have the same code for paper and scissors as well. Our next piece of code is the code that trains the model. So there is another handy method called train, pretty straightforward. And then remember that we want to minimize our loss, right? So the training process will keep on going until we have minimized our loss. And yeah, this code will get the move of the players using the classify method. So this is where, like I start playing and then, I give them my moves and then it will like classify it. You can just use the method classify and it will capture the video stream and return the predictions. So let's here the prediction, the first prediction is rock and then scissors and paper. So it's already sorted in by the confidence. So we can just like get the first result to get the one with the highest confidence. And yeah, so there are other things that you can do with ML5JS. It's not just images, but also like things like sounds and text. You can create neural style transfer application or even sentiment analysis. And I think we still have a bit of time, so I'll show you another application that I built with voice. So with this application, you can scroll a website just by using your voice. So if you say up, it will scroll up. If you say down, it will scroll down. So not sure if there is a, okay. Up, down, down. So yeah, that's how it works pretty much. Down. So yeah, this application, of course, has to learn from voices. It uses the speech comments dataset. So this is a dataset that contains comments such as yes, no, and so on. And the files in the speech comments dataset were recorded in various devices by various users with different environments instead of like recorded in like a proper studio. So if it's recorded in a studio, the model will have trouble recognizing comments in noisy environments, right? So again, this is also something that I learned when I read the paper. Just like when we were using ImageNet, it's really important for us to know how the dataset was created. And just like how we usually use CNN for image classification, for sound we usually use techniques such as recurrent neural networks. But in this example, I'll show you how we can do sound classification with CNN, just like we did with images. So this technique is explained in this paper. So if you're interested to learn more about it, you can like read the paper as well. And the advantage of this technique is that it's simple, quick to train, and very easy to understand compared to other techniques that may be more complex. So the key to the technique is that we're going to convert sounds into images. So that's why we can use like CNN. So these images are called spectrograms. And the spectrogram will be the input of the CNN. So now it's starting to look like image classification, right? And the CNN will give the predictions whether it's up, down, or like other sounds. And the great thing, ML4JS also already has a method that we can use right away. It's called sound classifier. So far, the supported model is speech comments 18W, which is the model that is trained on the dataset that I showed you earlier. You can also set the threshold here, up there. So that's the option. So if the model captures a sound, but it's not confident enough, the probability is less than 0.98. It's not going to act on it. It's not going to do anything. So after we give the permission to access microphones, our classifier will listen to the sound of the input. And once it hears something that is above the probability threshold, it will scroll the page according to what it hears, either up or down. So that's the classify method. And then scroll page is like the function for scrolling the page either up or down. So yeah, this is the function. It will get the result, whether if it's down, then it's gonna scroll down. If it's up, then it's gonna scroll up. Okay, so there are so many more. There are a lot of algorithms or methods that you can check out in ML5JS. So you can just go to ML5JS.org/reference. And there is actually another thing that we can do, which is building our very own model from scratch. This means that we can determine our own layers and parameters and so on. So if you want to know how to do that, you can just come to my workshop, the Introduction to TensorFlow.js workshop today. So yeah. All right, so what's next? So if you want to learn more, these are some great resources that you can browse. There is a beginner's guide to machine learning in JavaScript, which is a series of videos on various applications of machine learning in JS. There's also a library called Magenta.js, which is by Google as well, if you want to create art and music with machine learning. This is the Coursera course that everyone takes, which is also good. There's a reason why everyone's taking this course, because it's good. So if you want to learn more, you can check that out as well. If you're into hardware, you maybe want to combine machine learning and hardware. If you want to learn more about the source code, you can check out the ML5J source code to see what's going on behind the scenes. I think it's going to give you a lot of more understanding on what's going on, and it's great. And the last one is that bias in machine learning. So I think this is a very important ethical topics that need to be discussed if you're building machine learning applications. I recommend you to do, so machine learning is not all, sunshine and rainbows, right? So there are certain implications that you have to be aware of. And I think one of the books that I really recommend is Weapons of Math Destruction by Katie O'Neill. So if you want to read more about that, feel free to check out the book. So there are so many possibilities with what you can do, you can build using machine learning. So many tools as well. So hopefully you all get inspired to build your own machine learning web applications. So that's it from me. Thank you.